Okay, we're looking at some graphs that have something wrong with them. Okay, this first graph is misleading. So if you see a misleading graph, that's the first thing you say. Even better, make a slightly weaker statement could be misleading, but it certainly could, because, okay, what you have to do is say how someone could be misled. Now, the visual impression we get is that the amount in 1998, this is house prices, has got hugely bigger in 1999, because this block for 1999 looks about, well, on the page it is 3 times the area. So have house prices got 3 times as big? No, they haven't. They've only gone up from 80,000 to 82,000. The reason why the visual effect is misleading is because this value on the y-scale is actually starting from, well, following the pattern down, this would have to be 79,000. Okay? To get a correct visual impression for the areas of the blocks, the y-scale should start at 0. So how do we express all of that? Well, we've got to do 2 things. Firstly, we've got to describe the misleading effect that could be given and what the true situation is. So here's the impression we get, that house prices, notice we're in context, in 99 were 3 times as big as in 1998, when really, so we contrast the effect that's given with the real situation. So the increase from 80,000 to 82,000 is a percentage increase we're talking about, and that would be fairly small. You can even work it out if you want, but that's not strictly necessary. Okay, so we've described the misleading effect and what the real situation is. Now we have to talk about how the graph is wrong. Well, the problem was the y-scale did not start at 0, and it asks how should the information be represented. So we need to put that together. So the reason for the misleading effect is because the y-scale does not start from 0, and the way to put it right is to redraw it, starting the y-scale at 0. Okay, the one we just finished was a misleading graph. This isn't a misleading graph, okay, but it certainly has something wrong with it. Because we have no scales on either axis, there is absolutely no way of telling what this graph is about. So it's not misleading, it's just meaningless. We've no way of knowing whether, if we did label the scales, it would be a good way of showing what it was supposed to show. We just have to move on. Okay, so here's the next one. Okay, so this is slightly more subtle than when the y-axis is truncated, okay? But the first thing that's wrong with it is actually maybe the y-axis has been chopped off at 0. I've just have no numbers. So maybe the y-axis has been chopped off. I suspect it has, because it's making it look like the number of singles sold in 1998, comparing with the bar next, it looks like it's half what was sold in 1997. Now that sort of change is just not very likely to happen. Okay, so at that point, I'm going to put that one into the first problem, which is that I just don't have a vertical scale. But I can say something else is wrong here, because I think that whatever the vertical scale, this block for 1997, okay, trying to follow this line across, I think it's supposed to be the same height as the 1995 one. But because they've drawn this in 3D, the problem with a 3D diagram is you can often get the effect that 1995 gives a bigger visual impression than 1997, even though the numbers might be very similar. And that's because they've decided to put this perspective effect on it. So we can say that the 3D effect gives the impression that sales were higher in 95 than in 1997. So that's the first thing. Say what effect is given, okay, and then say what the real state of affairs is when really they were similar. Okay, so that last sentence there follows the template that you say what the visual effect is and you say what the real state of affairs is. Okay, so it looks like it's gone down from 1995 to 1997 when in fact it's probably about the same. And then finally, maybe the simplest example of the lot, okay, what is wrong with this pictogram? Okay, well, just one glance at this shows that they're drawing the horses much bigger than, say, for example, the cats. So the problem is that the pictures used are of different sizes. But we need to actually do the normal template, which is to describe an impression that could be got and explain what the real state of affairs is. So what appears is that horses are more common than cats, when really there were more cats than horses. So contrast the visual effect with the real state of affairs. That's all.